Hello, can you hear me? Anyone?
Yes, we can.
Yes.
Right, thank you. Okay, so we'll start now. Once again, welcome everyone. We'll be looking in today's session. We'll be looking at a few problems on integration by trigonometric substitution as well as partial fractions. And I'm sure by now you guys have had a chance to look at the worksheet. And before I start, I'd like to ask if you have any specific question that you'd want us to tackle. We tackled a few yesterday in the session, but right now it's now open to everyone. So if you have any questions that you found to be particularly difficult in the worksheet, let me know, and that's where I'll start. Otherwise, I'll just start from the beginning.
Jonathan,
Yeah.
hold on, sorry, my volume is a bit loud. Hello?
Yes, I can hear you.
I was going to ask could you please just give us tips on how to tackle questions? For example, you see our denominator as we have on that first one. Let's say now we didn't have the square root, instead we had brackets to the power of something, for example, 5/2 or 3/2. Please also show us how to do those ones, how to go about those.
3/2 or okay, so
like 5/2 or 3/2 instead of that square root.
into the square. Okay.
Cool.
Yeah. Well, we'll discuss that. I'll try that. Yeah.
Sure.
Okay. Just give me a minute. Please mute yourselves as you're joining. Right. So, like I was saying, as I guess since no one has a specific question on the worksheet, I'll just start from the beginning. So let's take, for example, the first example here, and then I'll explain more about the different exponents and stuff. So for this first example here, I'm not sure if you guys have had a look at the video that I posted on dealing with trigonometric substitution. So basically, there are a few rules, right? If you have the square roots of some constant squared plus x squared, or some constant squared minus x squared, or x squared minus the constant squared. So there's a few rules that you have to apply when you deal with those types of trigonometry of expressions when you want to use trigonometric substitution. And in most cases, you will end up using trigonometric substitution for those, right? So for this one here, you can rewrite this expression as the integral of 1 over 1 minus x squared to the half, right? dx. Now, to the question that was just asked earlier, this exponent can be anything, basically. It can be half, it can be 3/2, it can be 5/6, it can be anything. But as long as you have that expression there, the 1 minus x squared, then immediately, based on, at least in general, right? There might be some exceptions here and there, but in general, as long as you have this expression 1 minus x squared, immediately it tells you that you have to use it trigonometric substitution, and you have to substitute x by sine of u, right? And well, in general, it should be a sine of u, but in our case, a is 1, right? Because you have 1 squared basically minus x squared, and a is just 1. So we have x is equal to sine u. So that's the substitution that we'll be using here, right? So there are a few rules on this. Just maybe I guess my advice would be just revise those rules. When you have 1 minus x squared, when you have, sorry, a constant minus x squared, or plus, just revise those rules, but because they should apply in most of those cases, regardless of the exponent there, right? So let's try that. So now, if you have x is equal to sine u, then it means that u is equal to arc sine of x, right? So we're still together up to that point. So now, that means that dx is equal to cos u du. So now we can bring that into the expression, and it becomes, right, the integral of 1 over 1 minus sine squared of u, right, to the 1 over 2, right, and dx is just cos u du, which can be simplified further to be basically cos u du divided by 1 minus sine squared is just cos squared, right? So you have cos squared u to the 1 over 2, which will just become cos u, right? So you have, you can simplify the cos there, so you'll be left with du. And the integral of du is just u, right? Plus the constant of integration. And we know that u is arc sine. So the answer is just arc sine of x plus c. Right, so that should be your final solution. Right. Now, just for the purpose of this case, in most cases, as you will see, the denominator of the exponent, right? So it will always sort of make it easy for you to be a square there. It will be a 2 there. Because in that case, when you do your substitution, you can easily simplify that 2, those 2. Yeah, I'm not sure if what I'm saying makes sense. So, well, not here, obviously. It'll have to be here. So you can simplify easily those 2 there. So in most cases, I think you'll more likely deal with an exponent that has something over 2, right? Over 2 always, because that makes it easier for you to simplify. Now, if you have something like 3 over 5 or something that's not 2, then the integration becomes a little bit, I would say, difficult, close to even impossible in some cases, impossible to solve. So you don't have to worry about it, I think, but because in most cases you will always be dealing with some sort of a version of what we have here, right? So yeah, that's for that. So the same would apply if you had the expression, for example, 1 over 1 minus x squared to, I don't know, 3 over 2 or 5 over 2, right? As long as it's over 2 there, then you have an opening to use trigonometric substitution, right? At least as far as I know. Is when you change the 2 there to another value, then it slowly becomes more and more impossible to solve the integral. Right. So, but I want you guys to attempt it and tell me if you can get to something. Right. So, any questions on this before I move on? Maybe I can give you some sort of homework question. Try this, attempt this integral. First attempt 5 over 2 dx and attempt 5 over 3 dx. Try that. Attempt it, tell me if you get to something. Okay, you can use this as practice for your upcoming test or something, or even to help you understand the expression, the concepts even better, right? I can suspect that you won't be able to find an integral to that question, but I want you to attempt actually and see if it agrees with what we are saying here. Right. So next question, we have the integral, and this question we did it yesterday, but I guess for the sake of everyone, I'll just repeat it. We have the integral of x squared of 1, over x squared multiplied by the square root of x squared plus 4. Right, so now based on those rules, right, you guys have had the rules, I'm sure, in your notes. What sort of trigonometric substitution should we use here? Right, and this is, and I'm not sure if you remember, this is stuff that I covered as well in the video that I did towards the beginning of the semester on trigonometric substitution. So if it might be helpful to you, you can always just refer back to that video and see if it helps you understand the concept. But anyway, so what sort of trigonometric substitution do you think we can use there for this specific problem?
Tan theta.
10, right. So the general rule tells you have to use a tan theta. It could be tan theta, tan u. It really doesn't matter at that point, but in our case, what is our a?
Two.
Right, 2. Hopefully everyone gets where the 2 comes from, because if you can rewrite this expression as the integral of 1 over x squared multiplied into x squared plus 2 squared, right? And that's where the 2 comes from, right? Based on your formulas, so general rules. So now that you have that, that means that theta, is equal to tan inverse of x over 2, right? So now that we have that, we know that dx therefore will be equal to what? That's my question to you guys. What will be dx?
2 sec squared theta.
Right, thank you. So 2 sec squared theta, d theta, right? So now let's apply it to the expression. We have 1, the integral of 1 over x, we know is 2 tan theta, so that will be 2 tan theta squared multiplied by the square root of 2 tan theta squared, right, plus 4, right? And dx is just 2 sec squared theta d theta, right? So now, moving on, this can be simplified further to be, we can first simplify this 2 here and the 2 there, right? And we take out the 1/2 that's left, so that would be 1/2 outside multiplied into sec squared theta d theta divided by 10 squared theta multiplied into 4 10 squared theta plus 4, which is equal to 1/2 again multiplied by the integral of sec squared theta d theta divided by 10 squared theta. But now since 4 is a common factor between the two here, we can take it out. And when you take it out of under the square root sign, it becomes 2, right? So you have another 2 coming out here, multiplied by the square root of 10 squared plus 1, right? Again, this is equal to 1. We can take out the 2 there, so that will be 1/4 outside, multiplied into the integral of sec squared theta d theta divided by 10 squared theta. And what is 10 squared plus 1 equal to? In fact, what is this entire square root equal to?
Sec theta.
Sec squared.
Sec theta, right? So that would be sec theta. The sec theta can cancel with that, right? And you have 1/4 multiplied into sec theta d theta divided by 10 squared theta d theta. Right, so now we know that sec is equal to 1/cos, right? And tan is equal to sine over cos. So let's use those expressions. So we have sec now, 1/4 multiplied into the integral of 1/cos theta d theta divided by sine theta divided by cos theta squared, right? You're dividing two expressions, so you multiply the first one by the inverse of the second one, and you should get cos theta, 1/4 multiplied by the integral of cos theta over sine squared theta d theta. So now at this point, what do you guys think we can do? How do we solve this?
Use substitution.
Right, u substitution. So what do we use as our u then?
Sine.
Let's try sine. So let's use sine. U is equal to sine theta. That means that du is equal to cos theta d theta, right? And therefore this can be simplified to be 1/4 multiplied into the integral of, right? Cos theta d theta is just du. So you have du divided by u squared, which is equal to 1/4 multiplied by the integral of 1/u squared. You know that is just the same as the integral of u to the negative 2 du, which is 1/4 multiplied by u to the negative 2 plus 1, right? Divided by negative 2 plus 1 plus c, which can be simplified to be 1/4 multiplied into multiplied by u to the negative 1 over negative 1 plus c, and that can just be negative 1/4, and we know that u is sine theta, so we have sine theta to the negative 1, which is just 1/sine theta plus c, right? which is equal to, remember now, let's go back to what theta is. Theta is tan inverse of x over 2. So we have 1 over 4, negative 1 over 4, sorry, multiplied into 1 over sine of tan inverse of x over 2, right, plus c. Now we know from our trigonometric expressions that if theta is the angle here, right, we know, and this side is A, that side is B, we know that tan of theta, opposite side over adjacent, right? So A over B, right? So in our case now, we have that A is equal to X, right? So A is equal to X and B is equal to 2, right? So now we have that, again, theta is equal to tan inverse of A over B, which is just X over 2. And because we know that, then therefore sine of theta is what? Sine of theta is opposite over hypotenuse, right? So the opposite side over the hypotenuse, and the hypotenuse is just the sum of the squares, the square root of the sum of the squares. So we have x squared plus the square root of x squared plus 2 squared, which is 4, right? So sine of theta, which is the sine of tan inverse of x over 2, is just then equal to opposite, so x over the hypotenuse, which is x squared plus 4, the square root of x squared plus 4. Now you take it back to that expression, and that should be your final answer, right? So for the sake of space, I'll just leave it out there, and I'm sure you guys can continue from there. Right, any questions in this? Anything at all? Any comments? Okay.
It's me.
Yes, go ahead.
There is a part where we converted under the root. We had 4 tan squared theta plus 4. Then we made that into sec theta. Is that like a standard thingy, or is it something we created?
Oh, yes, it's a standard equation. We basically manipulate it. So let me maybe, okay, I'll write it down here and then I'll just erase it. So let's forget about this question for now, just to explain the concept. So we have square roots of tan, so we have 4 here, 4 tan theta plus 1. Oh, sorry, plus 4. 4 is a common factor, right? So we can take it out. So we have 4 multiplied by 10 squared theta plus 1. Now we can separate these two because 4 is just 2 squared, right? So when you take it out of the square root side, it becomes 2 multiplied into 10 squared theta plus 1, right? Under the square root sign. We know that 10 is sine over cos, right? So you have 2 multiplied by sine theta over cos theta squared plus 1, right? I hope you can follow up to that. Then this is equal to 2, right? Multiplied by the square root of sine squared theta over cos squared theta. But now you put it to the same denominator, right? As 1, and you have sine squared theta plus cos squared theta all over cos squared theta. And sine squared theta plus cos squared theta is equal to 1, right? So you have 2 multiplied by the square root of 1 over cos squared theta. And you know that 1 over cos is sec. So this is equal to 2 multiplied into the square roots of sec squared theta. And the square root of sec squared theta is just sec. So you have 2 multiplied by sec theta. Do you understand now?
Yes, thank you. Thank you very much.
No problem. Any other questions? Okay. So I think we'll move on to the next question now. Right, so the next question is